Imagine a shape that repeats forever, always the same yet always different. That's the essence of a fractal, a magical mathematical concept that we can see everywhere in nature. Welcome to the world of fractals. These patterns are not just natural phenomena, but also stunning works of art. Fractals are complex patterns that display self-similarity. This means that each small part of a fractal is similar to the whole, creating a magical harmony. Zoom in on a fractal and you'll discover miniature copies of the entire shape. This creates a sense of infinity, as if you could keep zooming in forever. This mesmerizing geometry exists between our familiar spatial dimensions, from majestic mountain ranges to the waves on a beach. Fractals are everywhere. Fractals are not just pretty pictures, they are also powerful tools that help us better understand the complex systems around us. From the movement of traffic in a city to the synchronized flight of birds, fractals help us recognize hidden patterns. From the branching of trees to the ruggedness of a coastline, fractals reveal nature's hidden order. These patterns are not only beautiful, but also contain the fundamental laws of the universe. The beauty of fractals lies in the infinite complexity arising from simple rules. From basic principles, they create complex and diverse images. This paradox makes them a magical inspiration for both mathematicians and artists. Fractals are not just a mathematical concept, but also a bridge between science and art, opening up new horizons for creativity and discovery. Benoit Mandelbrot, a Polish-born mathematician, coined the term fractal in 1975. He recognized the limitations of traditional geometry in describing the rough and irregular shapes found in nature. Mandelbrot argued that clouds are not spheres, mountains are not cones, and lightning does not travel in a straight line. He showed that fractals, with their fractional dimensions and self-replicating patterns, provide a better model for understanding these natural phenomena. His groundbreaking work, using computer graphics to visualize fractals, revolutionized our understanding of geometry and its applications. Look around and you'll find fractals everywhere. From the delicate veins of a leaf to the majestic branches of lightning, nature uses fractals to create complex and efficient designs. Snowflakes, with their six-fold symmetrical shape and intricate branching, are perhaps the most iconic example of fractals in nature. Each arm of a snowflake is a miniature copy of the whole, demonstrating the principle of self-similarity. Mountains also exhibit fractal patterns. Their jagged peaks and valleys repeat at different scales, creating a landscape that is both rugged and beautiful. Part 4. Fractals in our backyard. Even in our daily lives, fractals surround us. The branching patterns of trees and rivers, the rough texture of cauliflower, and the swirling patterns of seashells all hint at the underlying geometry of fractals. Next time you're at the beach, take a closer look at a seashell. You'll notice that its spiral shape follows a pattern called the Fibonacci sequence, another mathematical concept closely related to fractals. Fractals are not limited to the natural world. Human-made structures, such as antennas and the Eiffel Tower, also incorporate fractal designs for their strength and efficiency. Part 5. Fractals in technology, from antennas to special effects. The unique properties of fractals have led to their application in various fields, including telecommunications, medicine, and computer graphics. Fractals, with their repeating structure at different scales, offer superior benefits that traditional technologies can hardly match. For example, fractal antennas are smaller and more efficient than traditional antennas, making them ideal for use in mobile devices. These antennas not only save space, but also improve signal reception and transmission performance, helping mobile devices operate more stably in environments with a lot of signal noise. In medicine, fractal analysis is used to study the complex patterns found in brainwaves, heartbeats, and even DNA strands. Scientists can use fractal patterns to detect even the smallest abnormalities in biological patterns, thereby helping to diagnose dangerous diseases early. This helps diagnose diseases and understand biological processes. By analyzing fractal patterns, doctors can develop more effective treatments, thereby improving patients' quality of life. Computer graphics relies heavily on fractals to create realistic landscapes, textures, and special effects. Software developers use fractal algorithms to simulate natural phenomena such as clouds, mountains, and trees, bringing vividness and realism to digital products. From breathtaking scenery in movies to immersive worlds in video games, fractals bring digital creations to life. The majestic landscapes and special effects in movies and video games not only captivate audiences, but also open up endless creative possibilities for artists and developers. Part 6. Infinite Zoom. A journey into fractal dimensions. One of the most fascinating aspects of fractals is their fractional dimension. Unlike traditional geometric shapes which have integer dimensions, a line is one-dimensional, a square is two-dimensional, and a cube is three-dimensional. Fractals exist between these dimensions. Imagine zooming in on a fractal. Instead of becoming smoother like a straight line, a fractal reveals more detail and complexity with similar patterns repeating at smaller scales. This infinite zoom is a hallmark of fractals and illustrates their unique ability to pack an infinite amount of detail into a finite space. Part 7. The enduring allure of fractals. Fractals, with their blend of mathematics, art, and nature, continue to captivate our imagination. These shapes are not just abstract concepts, but observable phenomena in the natural world. They remind us that beauty can be found in the most unexpected places, and that complexity can arise from simple rules. From the interwoven branches of trees to the unfurling fern leaves, fractals are everywhere. Whether we are admiring the intricate patterns of a snowflake, with each flake a unique masterpiece, or exploring the infinite depths of the Mandelbrot set, one of the most famous icons of fractals, we are drawn to their magic. Fractals offer a glimpse into the underlying order and beauty of the universe. The veins of a leaf or the salt flats from above are all testaments to the presence of fractals in nature. As we delve deeper into the world of fractals, we not only see beautiful shapes, but also discover fundamental principles of nature. We will unlock new possibilities in science, technology, and art. From the honeycomb structure of bees to the spirals of galaxies, fractals help us better understand the structure and evolution of the universe. The journey into fractal dimensions is a testament to the power of human curiosity. Scientists and explorers are constantly searching for and exploring the mysteries of fractals in nature and our endless journey to understand the world around us. From children playing in a forest to hikers exploring dense woods, fractals are ever present, enriching our lives.